Alright, welcome to our 6-3 lesson video. We did cover a lot of this in class. I do want you to make sure you're paying attention though, because you might pick up on something that you missed. In lesson 6-2, we looked at if we knew something was a parallelogram, then we noticed all these different characteristics and traits. Kind of you can see that from what we filled out. We had these 5 main traits or properties of parallelograms. So we're just putting this in reverse order today. We're going to look at quadrilaterals that have these properties and use that to say, well, then yes, it is a parallelogram. Okay, the objective is to prove or verify or justify that a given quadrilateral is a parallelogram. We've learned to identify the properties of a parallelogram. Now we're going to be given those properties of any specific quadrilateral, and we'll have to tell if that quadrilateral is a parallelogram. We can do this by using the definition, and you remember what the definition is. Parallelogram is a quadrilateral with parallel opposite sides. Remember, that needs to be both pairs of opposite sides. And then we have these other conditions that could be met. We talked about those in class, and hopefully you've had a chance to write those down. Again, you're going to look for page 413 to find those charts, and they are out of order. I didn't realize this for all the classes. I know I pointed it out to a few of you, but this order of the pictures is not the order they are given, and so your chart needs to look like this. Okay, since this is the first picture you're given, you actually want that last one in the book chart, and that's about having one pair of opposite sides that are congruent and parallel. Then it's a quadrilateral. And so then the rest of these are kind of in order. And they number them in the textbook for you, 6-9, 6-10, 6-11, and 6-12. And so just pay attention that actually the one that says 6-12 is the first one you're going to write in your notes. So if you need to change that order, you might want to make sure you do that, or draw arrows to the correct pictures so you can make sense of your notes later on when you're looking at them, because what good are notes if you don't look at them later when you're supposed to be studying? Okay, so we looked at example 1 on how to use these conditions to see if it is a parallelogram. And so we showed that this was a parallelogram by showing that when we plugged 3 in for A, these sides are the same length, so they're congruent. And when we plugged 9 in for B, we got congruent sides up and down. So we do have a quadrilateral with 2 pairs of opposite sides, so it is a parallelogram. 2 pairs of opposite sides that are congruent, sorry. And then in part B, which again, pay really careful attention to this, pause the video if you need to, we plugged in 2.4 for A to see if these sides were congruent, but then we used these angle measurements and we plugged 9 in for B again, and we got 74 degrees and 106 and realized these are supplementary. 74 plus 106 does equal 180. So they're supplementary angles. That means these consecutive angles are supplementary, so these sides are also parallel. So we were able to show that we had one pair of sides, QP and RS, that are parallel and congruent. That means it's a parallelogram. All right, and then on the rest of these, we kind of went over how to tell if they were a parallelogram or not based on those given facts. And either we had one of those 5 things we could talk about, either we had one of these 5 things, and the 5th being the definition, like opposite angles are congruent, or we didn't have enough information. Okay, so A was a parallelogram because opposite angles are congruent. B is not necessarily a parallelogram. We only know one pair of opposite angles are congruent, not both. C, also not enough information. We only have one pair of opposite sides parallel. D, there's a couple different ways you could have done this. In most of the classes, I showed you that we could show that the triangles are congruent, so these opposite sides are congruent by C, P, C, T, C. Corresponding parts of congruent triangles are congruent. But then we also looked at in, I think it was 7th hour, noticed that if I have alternate interior angles here, and then the third pair of angles here and here are congruent, then these sides are also parallel. So we have opposite sides that are parallel too, and that could be a reason why they're a parallelogram. And then in E, no, not a parallelogram because we don't have the right information. We have the wrong sides given. Okay, these are consecutive sides that are congruent, not opposites. F is a parallelogram because opposite sides are congruent. G is a parallelogram because the diagonals bisect each other. H is not a parallelogram because there's not enough information. We only have one pair of congruent sides. And then I is a parallelogram, and here's why, in case you missed that. We have one pair of sides that are parallel. These arrows mean they're parallel, and they're the same length. They're both 5, and that means they're congruent and parallel. So we have one pair of opposite sides that are congruent and parallel. That makes it a parallelogram, just like example 1b. All right, and that allows us to finish out the notes with talking about these coordinate geometry problems. Okay, we have example 3. In example 3, we are going to use what we know about the coordinate plane and how to plot points, how to use distance formula, how to use midpoint formula and slope and things like that with what we know about parallelograms to justify or prove that each given quadrilateral is a parallelogram. So I give you the 4 points to plot. I want you to plot those on your own, so you'll want to pause the video, otherwise it's just going to pop up on the screen in just a second. And just like that. So we get this quadrilateral with points J, K, L, and M, and we want to use the definition of a parallelogram to show that this is a parallelogram. Remember, the definition of a parallelogram is that there are two pairs of opposite sides that are parallel. So I want to show that KL is parallel to JM and show that KJ is parallel to LM. Remember, on the coordinate plane, to show that lines are parallel, you show that their slopes are the same. So we want to find the slope for KL and JM. Remember, that's rise over run. So from KL, we go up 1, 2, 3, 4, 5, 6. For a rise, run is 1, 2, 3, 4, 5, 6, 7, 8 for the run. So that's 6 over 8, which is 3/4. Want to try the same thing for JM. 1, 2, 3, 4, 5, 6 for the rise again, and 1, 2, 3, 4, 5, 6, 7, 8 for the run again. 6 over 8 is also still 3/4. So we can say KL is parallel to JM. And then we're going to do the same thing for KJ and LM. All right, I'm going to let you guys count the slope for each of those. Tell me what those are. Check your answers by clicking play in a second. And we'll show that these are parallel. All right, this is what we should get for the slope for KJ and JM. I'm sorry, LM. Sorry, LM. This side. Both of these slopes are -5/3, down 5 to the right 3, down 5 to the right 3. Since they both have a slope of -5/3, KJ is parallel to LM. Since we have two pairs of opposite sides that are parallel, we can say JKLM is a parallelogram. All right. All right, example B, we're going to do the same kind of thing we just did. I want you to plot points A, B, C, and D, and you should get a quadrilateral that looks like this. A, B, C, D. And we're going to prove that it's a parallelogram by looking at one pair of opposite sides that are parallel and congruent to show that it's a parallelogram. Now, we just need to pick two opposite sides to do. I'm going to choose AD. I'm going to pick AD and BC. I could choose the other two sides, the longer ones. It doesn't really matter, but I'm just going to focus on AD and BC. And I'm going to show that those sides are both parallel because they have the same slope, and they're congruent. So I'm going to use slope, and I'm going to use the distance formula. Okay, I'll make you a little table here. The slope of AD is rise over run. We can look at it really easily. We go up 2 over 1. The slope of BC, again, is up 2 over 1. Okay, so they have the same slope. Therefore, remember this little symbol of 3 dots in a triangle means the word therefore. AD is parallel to BC. Okay, so we have a pair of opposite sides that are parallel. Now we're going to use our distance formula Okay, we're going to go back to these coordinates, A and D first. We're going to do the difference of the x values, 1 minus 2, and square that, and the difference of the y values, 1 minus 3. Square that. 1 minus 2 is negative 1. Negative 1 squared is positive 1. 1 minus 3 is negative 2. Negative 2 squared is positive 4. So that becomes 1 plus 5 in the radical, which is root, or square root, 5. So we leave it like that. AD is square root 5. So we're going to try the same thing for BC. We're going to use these points. Difference of the x's, 6 minus 5 squared. Difference of the y's, 2 minus 0 squared. 6 minus 5 is 1. 1 squared is 1. 2 minus 0 is 2. 2 squared is 4. So once again, we get square root 5. That means that AD is congruent to BC. So we have one pair of opposite sides that are both parallel and congruent. So ABDC is a parallelogram. All right, and that wraps up the examples for this lesson. We don't have a whole lot more to do. I want you to try and fill out this graphic organizer at the end to come up with a sketch in each of these boxes for the 5 conditions for a parallelogram. 4 things came from that chart, and the 5th one was the definition. You got to look back at those and see what they say. But try and have these filled out so we can talk about them on Tuesday. Remember to also do the assignment for 6-3 to the best of your ability, and we will go over questions when we get back to school.